Recording. Two formulae are there which are very important for today's session. Limit x approaching 0, sin x upon x is equal to 1. Limit x approaching 0, tan x upon x is 1. Okay, so these two formulae are very important. And these two formulae are applicable only when there is sin and tan. Okay, it's not applicable for any other uh, trigonometric function. Okay, it's not really applicable for any other trigonometric function. It is only applicable for sin and tan. Please copy. Fine. So let's go to the first problem which is shared with you all in the exercise 7. Question number 1. Limit x approaching 0, sin 2x upon x. Okay. Now first and foremost, I have given you these two formulae. X should be approaching 0 only, yeah? Not any other value. It should be approaching 0. Okay. Now the logic to apply this particular formula is supposed to be understood well. You cannot randomly apply the formula anyhow. The formula says whatever angle is there of sine, whatever angle is there of sine, down also it should be the same angle. Or down also it should be the same value, not angle, but then same value of the angle. So is it same? Sine has angle 2x over here. Is it same in the denominator?
No.
No. So we have to make it same. That's how we have to apply the formula. And to make the value of the angle same in the denominator, I'll multiply and divide by 2. I'll multiply and divide by 2. Okay. Now we made the same angle. The angle is made same. See? Now we can apply the formula. Now this is formula application. Okay. As per the formula, this becomes 1 and this is 2. And 1 into 2. This constant is written over here. 1 into 2 is 2. Did you understand?
Yes, sir.
Okay. Now one question to all of you. If it is 3x over here, if it is 3x over here, so down, which value is supposed to be there?
3x.
3x, correct. So in that case, we'll have to multiply and divide with 3. Okay. Yeah. Question number 2. I hope everybody has copied this. Limit x approaching 0, tan 2x upon x. Okay. So limit x approaching 0. This is 2x over here. So down which value is required so that the formula is applicable? Down which value is required?
2x.
Correct. So to make it 2x, what we need to do? If I have to make 2x over here in the denominator, what we need to do?
Multiply, divide by 2.
Multiply, divide by 2. Okay. Now this part, as per the formula, this part as per the formula is what? What is this yellow colored part?
1.
This is 1. So 1 into 2, this 2 is over here, is equal to 2. Okay, please copy. And the formula is applicable only for sine and tan. Okay. Next question. Question number 3. Limit x approaching 0, tan of half x upon 3x equal to, okay, tan of x by 2, 3x. Okay. So this half x I have written x by 2, right? Now what is the angle of tan? What is the angle of tan?
X by 2.
Correct, x by 2. So here what term is required?
X by 2.
X by 2. 3 has nothing to do with it. So I'll separate this 3. I'll separate this 3 into 1 upon 3 I'll write. 3 has nothing to do with x by 2. 3 is not required over there. And in the next step, I'll make it x by 2. Multiply and divide by 2. But then this time, this 2 is supposed to be written over here so that we can cancel it. Okay. You don't have to cancel, but then that 2 is adjusted over there. Now this part, this particular part, the one marked in blue, is what?
It's 1.
It is 1. Okay. 1 upon, this is 1. 1 upon what? Anyone? 1 upon?
1 upon
1 upon 6. One upon 6. And one small note you write down for your school teachers. Okay. If x approaches 0, then x by 2 also approaches 0. Okay. I forgot to write it in the previous problems also. In the previous two problems you write, if x approaches 0, then 2x also approaches 0. Okay. This was for question number 1 and 2. And here you write, if x approaches 0, x by 2 also approaches 0.
So could you explain how you got that 2 in the denominator? You made it like the x by 2 into 2.
Yeah. Now tan x by 2 upon x. The 3 got eliminated, right?
Yeah,
So now this 2 is beneath this x, right?
yeah, correct.
So to eliminate this 2, we have to write this 2 over here.
Okay, understood, understood. Thank you, sir.
Yeah, yeah. Let's go to question number 4. Let's go to question number 4. Limit x approaching 0, sine square 5x upon sine 15x. Okay, now there are two sine terms in the numerator. Okay, there are two sine terms in the numerator. So I'll just write it as sine 5x into sine 5x upon sine 15x. Okay. Yes, now I require some answers from you all. And please respond, guys. For the first sign, there is 5x over here. Okay. So as per the formula, beneath this sign, what should be there?
5x.
Is there 5x?
No.
No. So we'll multiply and divide with 5x. See how I'm writing, okay? Limit x approaching 0, sine 5x, and this is 5x. Fine. So there was no 5x. So I just multiplied and divided with 5x. Now there is one more sine 5x in the numerator. The angle is 5x over here. So beneath this sine 5x, what should be written?
5x.
5x. So again, I am going to multiply and divide with 5x. Sine 5x multiplied and divided with 5x. Now this should be easy for you all. The last term. This is sine 15x. Girls, can you respond? What is the angle of this sine? What is the angle of this sine?
So 15x.
Correct, 15x. So down which term should be required for that sine?
5x.
5x.
What?
15x.
15x.
Oh, here.
So 15x is required. Okay.
But can't you
And
just multiply it up?
so eliminate this particular 15x by writing a 15x over here. Okay. Yeah. Is anyone not understanding this? I'll just wait before I answer the next step. Before I explain the next step, I'll just wait if you want. You may ask
So
your
you can
doubts.
multiply it in the numerator also, na?
No, 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 no.
Isn't there
See,
the identity x by sin x also?
yeah. That is also fine. That is also fine. But then, that becomes confusing at times.
Okay.
Okay. Now see, the ones which I'm marking in red. Now this red color circles are what?
1.
1.
These are one. Okay. Now 1x and 1x will get cancelled. Or this x and this x will get cancelled. So we are left with 1x over here, and that x is not in the denominator. Our problem is x should not be in the denominator because x will be 0 otherwise. It's in the numerator, so that's not really a problem. So even if you cancel 1x and 1x over here, okay, there is 1x which is still remaining. Okay. So see, these are the three ones. 1, 1, and 1. Okay. These are the three ones. Then 5 into this 5 is 25. This 15 is over here. Okay. Now this x is approaching 0. That you put it over here into 0. So the answer is 0. Anyone wants a re-explanation on this?
So how do you get x equals to 0 in the numerator? Can you explain that?
Speak loudly.
So can you just explain again how you get x equals to 0 in the numerator?
Because there is one x left over here, Tan. It is not getting cancelled, nothing is happening with it.
So we take it as 0.
We take it as 0. Yes. Tan,
Okay,
have you
sir,
gone
thank
through the
you.
2 recordings?
Not yet, sir.
You have to.
Of limits, no. Okay.
Yeah, yeah.
Yes, sir. I'll do it today.
Okay. So now, guys, this particular x which was left over here, there is no way we can eliminate this particular x. So we are putting this x as 0. Okay. Next problem. Question number 5. Limit x approaching 0, sin ax upon sin bx. Acha, one thing we forgot to write over here in the previous problem. We have to write, okay, that x approaches 0, so 5x also approaches 0 and 15x also approaches 0. Because we are applying the formula for 5x and 15x, no? That's why. X approaches 0, so 5x and 15x also approaches 0. Fine. Next problem. Sin ax upon sin bx. Sin ax upon sin bx. This is sin ax. Now beneath this sin ax, which term is required? Beneath this sin ax, which term is required?
AX.
Ax. Now that term is not there. Not even a single x is there. So we'll multiply and divide with ax. Now beneath this sin bx, which term is required?
bx.
So divide by bx, multiply by bx in the denominator. Okay. Now this and this also, this x will get eliminated. It will get cancelled. Okay. Now what is the value of the red colored circles?
So 1.
This will be 1. So 1 into a, and down it is 1 into b. A and b are constants. Here we have applied the formula. And you're going to write x approaches 0. You're going to write over here at the end of the answer. Answer is a by b, okay? If x approaches 0, ax and bx, they also approach 0. X approaches 0, so ax and bx also approach 0. Fifth problem. Now you have question number 4 and sixth problem. You have question number 4 and 6 right in front of you. What is the difference between question number 4 and question number 6? Anyone? People, you are not responding, so I really doubt whether you are attentive or
There's a
not.
power in the denominator.
Correct. So in fourth problem, there is square only in the numerator, but sixth one, it has square at both the ends, in the numerator as well as denominator. So we have a scope of clubbing that. We'll group those terms which are having a power. Sin square ax, sin square bx. So first step, I'll just group these terms and I'll write a common square. I'll write a common square. Now look at sine AX. Look at sine AX. Which term should be there beneath AX? Sine AX. Beneath sine AX, which term should be there?
Yeah.
AX, correct. So we'll multiply and divide with AX only for the numerator. In the denominator, there is sine BX. So beneath sine BX, which term should be there?
BX.
BX. So multiply and divide with BX. Okay. Red color circles. Value is
1.
1.
1. Provided x should be approaching 0, both the formulae of sine and tan are applicable only when x is approaching 0. Okay. Guys, what about this x and this x?
It gets cancelled.
It will get cancelled. So this is equal to 1 into A, 1 into BD whole square. They are within the square. There is a square on the top. So the answer is A square by B square. Now for your school teachers, you are supposed to write something. X approaches 0, therefore AX also approaches 0 and BX also approaches 0. AX also approaches 0, BX also approaches 0. One extra problem I'll take. Tan root 2x upon 3x. Limit x approaching 0, tan root 2x upon 3x. Now we have a tan over here. Which value should be there down?
Root 2.
Ideally, it should be root 2x. This value should be there down. But then out of root 2x, x is already there. We just need root 2, as somebody rightly said. Okay, x is already there. But then primarily, I will eliminate 3. 3 is not required over there. So I'll write 1 upon 3. Now we require root 2x. X is already there. So we'll divide by root 2 and we will multiply by root 2. We will divide by root 2 and we will multiply by root 2. What about this?
1.
Correct. 1 into root 2 by 3, which is root 2 by 3. And for your school exams, you're going to write a note over here. As x approaches 0, then what will approach 0?
Root 2x.
Correct, root 2x. Wherever you apply the formula, na, that value you see, that also approaches 0. You write this, otherwise be ready to get 1 mark, cut from here, from the final solution. Even if your answer is right, they will cut your 1 mark. We have
Sir,
completed. Yes, beta.
so can you please explain again why you took? Okay, no, sir, sorry, got it.
Yeah, fine.
Sorry.
No problem. Let's go to question number 7. Let's go to question number 7. Limit x approaches 0. Sine square 3x upon x square. Now the best part over here is in the numerator also there is a square, denominator also there is a square. So I'm going to group this. Sine 3x upon x the whole square. So I'm taking square common outside. Yes, Vanchika, tell me which term is this? Yes, Arinjay, tell me which term is this? Arush, tell me which term is this?
So it's sine 3x, no?
Correct, that is sine 3x. So down what is required?
3x.
Out of 3x, x is already there. Do you agree with me?
Yeah,
So what is the manipulation required?
into 3.
So into 3, नीचे का x को be multiplied by 3 and to eliminate that 3 we have written 3 over here. Everybody understood this?
Yes, sir.
Great. What is this yellow colored circle?
1.
1.
1. But then it is within the square. So 1 into 3 the whole square, that is 9. Tan, after this one note you are supposed to write. What is that note?
If x approaches 0, then 3x will also approach 0.
Correct. This note has to be written. This note has to be written.
Why is it necessary to write this note?
See, because I'll tell you, the formula is x approaching 0. So x and this is also x, right?
Yeah.
So if randomly we are making 3x, this cannot be x, now then this has to be 3x. So you multiply
Oh.
3 on both the sides. So
So yeah,
3x will also.
okay.
Okay. So it's a very small thing, but then they have every right to cancel your marks. Some teachers do not cancel, obviously, but then at school exams you're supposed to write this. Question number 8. Limit x approaching 0. Tan ax upon tan bx. Tan ax upon tan bx. Now similar type of problem we have solved. So yes, all girls, please reply. There is tan ax over here. So what to do with tan ax?
We divide by tan x.
Multiply and divide by ax.
By ax. Good. We multiply and divide by ax. Perfect. Boys, please reply. What to do with the denominator?
Multiply divided by bx. Multiply divided by bx.
Multiply divide by bx. Okay. Any term getting cancelled?
So from ax and bx, that's outside the x will get cancelled.
Correct. So this x is getting cancelled. What about this red circles?
So
We'll
1,
equate them to 1.
Correct. They are going to be 1. So 1 into A, 1 into B. You can write this within the box, not a problem. Which is equal to A by B. What are you going to write towards the end?
so ax approaches
So
0.
then ax and bx
If
approach 0.
AX approaches 0, AX also approaches 0 and BX also approaches 0. Okay. Just mention this for your school teachers. Let's go to question number 9. If you have copied this. Okay, so I think everybody should have copied this.
Yes, sir.
Limit x approaches 0, sine square x upon 2x. Okay, now let us first analyze this problem. Sine square x upon 2x. Let us first analyze this problem. Now there is square at the top, but then down there is no square. So we cannot really group by taking a common square. So sine square x can be written as, anyone?
Sin x the whole square.
Correct, but then I will prefer this. Sin x into sin x.
Sir, in school they had given us a formula saying sin square x upon x square is also 1.
See, now that is a derived formula.
So,
The
but can
basic
we use it?
formula. If you ask me, I can tell yes in a way, but then
Okay, sir.
somewhere something feels not right about it.
Yeah.
So this is 2 and this is x. So this 2x I'm writing as 2 into x. So somebody asked right now ki x square, that formula we can apply. In this problem it is not applicable because there is no x square down. Okay. So 2x is written as 2 into x. I'm teaching you the method which is applicable for each and every problem, where I'm keeping only two basic things, this and this. Now, apart from this, if your school teacher is asking you to do something, if you're understanding it, applied. Otherwise, I am there for you and follow my methods. Okay, now I'm asking about this blue colored circle, blue colored box rather. What is the value of this?
So 1.
1.
1. Perfect. This is 1. This red colored box, what is the answer? This is not 1. Okay, because in the numerator we have x and in the denominator we have 2. Okay. So I'll teach rather a long cut, one step extra, not very difficult thing that I'm trying to communicate. Now there is x over here. So this sin x will require which term beneath it?
X.
Correct. So multiply and divide with x, and this 2 is written over here. Okay. And this term, I'll just write sin x upon x. Okay. Once again, I will explain this.
So why can't we write 1?
We are writing it, don't worry. Okay, now this sin x upon x is 1, that will write towards the end, not now. Now this sin x, there is x over here, so we require x down. So multiplied by x and divided with x. 2 has nothing to do with it, so 2 is left apart. And this is written over here. Okay. Now this green colored circles. What is the value of these green colored circles?
So 1.
1.
Correct. So this is 1. This is 1. Okay. This 2 is written over here too. Now we are only left with this x, which unfortunately did not get eliminated. What to
So
do
but
with this
x is 0 now.
So
X
you
is 0.
substitute the 0 then.
Perfect. Put the value of x as 0. So the final answer is 0. And in this problem, there is no need to write any note because x is x only everywhere. It is not changing to ax, bx, 2x, 3x, nothing like that. So the answer is 0. Now you guys tell me, have you understood this problem? I rather took one
Yes,
more
sir.
step. to make you
Yes,
understand.
sir.
Purposely, I took one more step. Some teachers teach it by shortcut also, but then I definitely don't want to rely on that.
So I did it in another way. So in sin x upon 2, so I took sin 0, which is 0. I did 0 upon 2 directly.
Correct, correct. That is also
That
right.
works. Okay, sir.
But then I'm making you an habit to take the same angle down.
Okay,
So
sir.
that you'll always remember this as a method. Okay?
So,
Yeah.
so I took sin x upon 2x in the starting. I made that into sin 2x upon 2x, and then I did into 1 upon 2. So basically, I got
तो तू
sin
sin
2x,
2x कैसे किया लेकिन sin square x को sin 2x कैसे किया?
sin x into sin x.
हाँ, so is that sin 2x?
No, that's sin square x. No. So then
हाँ,
I said I did sin x into sin x upon 2x. So and then I took one half as sin x upon 2x, and then the other half as sin x. So then first half को sin 2x upon 2x into sin x upon 2.
no, something is incorrect over there.
So I'm getting same answer though.
Show your method. Come on, send it to me over WhatsApp.
Okay, so yeah. So that's
Yeah, let me check what you have done. Okay, so I also did this and you also have done till here, right? Now,
Yes.
what you are doing, Tan, you are directly multiplying the angle with 2, which is incorrect.
okay.
तू sin x को sin 2x कैसे लिख सकता है? That's not really applicable. How can you just multiply the angle with 2? हाँ, नीचे you can multiply. This is not an angle, na down.
Okay.
You understood why you are incorrect?
Yes, sir.
Okay. Next problem. I hope everybody is attending. I'm randomly calling out some names, but then those people are not responding. Just message them. Patak say they will come online.
So I will message them.
Okay, Mr. Arinjay. Yeah. Now, rather than me telling you, you tell me whether we can group the signs. Only tell me yes or no. There is sign up, there is sign down. Can we group the signs?
No.
We can't because the angle is different.
No, that is not the reason. We can't.
It's because it's
Angle is
cube
different.
in the numerator and square in the denominator.
Correct. Angle does not pose a problem over here. Okay, the problem is with the powers. Powers are different. Okay. So sine a theta the whole cube upon sine b theta the whole square. Chalo, did you understand this? I am not grouped, but then I'm just taking those powers outside. Tell me if you have understood this or not. Tell me, guys. No grouping,
Yes,
only
sir.
the powers outside.
Yes,
Trigonometric
sir.
function. Trigonometric function with a power goes outside. Now observe over here. I want all boys to reply over here. Okay. Bhansali, are you there? Rajvardhan?
Yes, sir. Yeah.
Great.
Yes, sir.
Shiv.
Yes, right.
Okay. Yes. Look at the term within the bracket. Sine A theta is there. So beneath sine A theta, what should be written?
A theta.
A
Eighty.
theta.
So what should be the manipulation?
Multiply and divide by 80.
Correct. Multiply and divide by A theta. Okay. Girls, Down in the denominator, there is sine b theta.
B theta.
Multiply and divide by b theta.
Multiply and divide by b theta. Okay. One basic question to all of you. Can I cancel this theta and theta? This theta and this theta. Can I cancel?
No, sir. No.
No, we cannot. Because upper it is cube and down it is square. So we have to do something else before we cancel it. Okay. So limit x approaching 0, sine a theta upon a theta, the whole cube, sine b theta upon b theta, the whole square. Okay. Now apply that cube to these terms. A cube theta cube, b square theta square. Apply this square to the b theta term. A cube theta cube, and down it will be b square theta square. Now can I cancel the theta? Can I write only theta? Yes or no?
Yes, sir.
Yes, sir.
Okay. Now tell me what is the value of this?
1 cube, which is 1.
Perfect. This is 1 cube. This part is 1 square. Okay. A cube upon b square. But then we are left with this theta. Okay. I think the problem is in terms of theta. I just copied it wrong, I guess. Okay, it's in terms of theta. Sorry. So what about this theta? There is one theta left. What about that theta?
So should I change it to theta?
That theta will be 0. So the answer is 0. Because there is only one theta left and it is not getting eliminated. So that is 0. Fine. And one note you write down. As theta approaches 0, a theta approaches 0, b theta also approaches 0, because we have applied the formula here and here. Okay. Again, I tell you, there is one theta left over here. It did not get eliminated. So there is no other option. We have to put the value of theta as 0 over here. Did we do question number 10?
No, sir.
Okay, we'll do question number 10. I forgot. Okay. And 11th problem, it is theta approaching 0, not x approaching 0. It is theta approaching 0. Look at question number 10 and think over it for a while. Okay, we'll start with question number 12. Sorry, question number 10. Limit x approaching 0, sine x square upon x. Now my first question to all of you, can this be written in this manner? Is this correct or is this wrong?
It's
Wrong,
wrong.
wrong, wrong.
Correct. So this is absolutely wrong. Okay. It cannot be written in this manner. Now observe the sine term in the numerator. Observe the sine term in the numerator. What is the angle of this sine?
X
Sir,
square.
0.
0.
It's X
Only
square.
angle I'm asking. What is
Oh,
the
yes,
angle
sir,
of this
sorry.
sine? No problem. So the angle of this sine is x square. So beneath, down, below the sine term, which term should be there?
X square.
X square. Very good. So to make it x square, इसको x square बनाने के लिए
Multiply and divide by X.
multiply and divide by x. So limit x approaching 0, sine x square upon x square into x. Okay. Yes, everyone. Yes, Prajna, Arushi, guys, can you just answer? What is the value of this?
So 1.
1.
Perfect, good. Yashvi, Aditi, what to do with this x? Yashvi, Aditi,
So it's 0, right?
correct. We cannot really do anything with this x. It will not get eliminated. Okay, so this x is left as it is. So x value is 0. So the answer is 0. One note you have to write. X approaches 0. So x square also approaches 0 because we applied the formula, na, that's why. Rehan, Keegan, you understood this?
Yes, sir.
Yes, sir.
Tan, Ania.
Yes, sir.
Yes, sir.
This was your question number 10. This was your question number 10. Let's go to question number 11. 11 we have done, sorry. Question number 12. Okay. Limit x approaches 0, sine 2x plus sine 6x upon sine 5x minus sine 3x. Multiple ways to solve this particular problem. There are multiple ways. I will stick to the one which I have taught you. Now this is sine 2x, sine 2x. So Shiv, beneath this sine 2x, which term should be there?
2x.
Correct. So multiply and divide with 2x. Yes, Krishiv. Beneath this sine 6x, which term should be there?
6x.
So multiply and divide with 6x. Yes, Arushi, sine 5x. So beneath this sine 5x, which term should be there?
5x.
So multiply and divide with 5x. Okay. And beneath this sine 3x, guys, which term should be there?
3x.
3x. Okay. Fine. So these circles are not really a problem for us.
So I got 4 as the answer.
Correct. So these circles are not really the problem. They are going to be 0. They are going to be 1, sorry. Okay. Now from the numerator, I'll take x common. And from the denominator, I'm going to take x common. Okay. So next step, limit x approaching 0, sine 2x upon 2x into 2. X is gone outside. I've taken it common. Plus sine 5x upon 5x into 5 Okay. X I have taken outside.
6x in the
6x, 6x. Correct, correct. Sorry. Down also you take x common. So sine 5x into 5, sine 3x into 3. And x is when x is going outside. Sine 5x into 5 minus sine 3x upon 3x into 3. These circles are 1. These circles are 1. So 1 into 2 plus 6 into plus 1 into 6 and 1 into 5 minus 1 into 3. At the same time, guys, what happens to this x?
Cancelled.
It will get cancelled because it was a common term and there is multiplication. So the answer is 8. X approaches 0. Therefore, 2x approaches 0. Therefore, 3x approaches 0. Therefore, 5x approaches 0. And 6x approaches 0. Okay. My method might seem to be a bit lengthy, but then
Where isn't the answer 4?
8 upon 2, that is
Yes, sir, it's 4, sir.
4. Sorry. I was saying my answer, my steps might seem to be a bit lengthy, but then you'll remember it rather than getting confused.
My teacher is doing this once in the past 10 minutes. I rushed it in 4 minutes.
What happened? Somebody's asking some doubt.
I completed 1, 2, 3, 4 steps. Why 4 steps?
Okay, question number 13. Question number 13. Limit x approaching 0 cos mx upon cos nx upon x square. Now guys, there is cos. We cannot apply any formula for cos. The formula is applicable only for sine and tan. So we'll apply factorization formula. Okay. Cos c minus cos d. Does anyone remember what is cos c minus cos d? Does anyone remember what is cos c minus cos d?
Cos C plus D by 2,
by
cos
2
C minus D by
cos C
2.
minus D by 2.
2 sine c plus d by 2 sine d minus c by 2. X square. So I think whatever formula you said was incorrect. Guys, do you remember this formula? We had taken a test on trigo, right?
Oh, wait. Oh, yeah, this is cos C minus cos D. Okay, yes, sir. You're right.
Yeah. So now here I'll take x common and here also I'll take x common. Fine. So limit x approaching 0 to sine m plus n upon 2 into x. Now this entire thing is the angle. This is theta into sine m minus 2 into x. Now there is x square down. So I'll give one x to the first sign and the other x to the other sign. So x square is distributed to the two different signs. Yes, now everyone. What is the angle of this sign? What is the angle of this sign?
M plus n upon 2x.
Correct, good. Out of that, x is already there. So what should be multiplied and divided over here?
M plus n upon 2.
M plus n upon 2. Perfect. This sign, the angle is m minus n upon 2 into x. X is already there. So what we have to multiply and divide this term with? Hello? What we
m
should
Minus n by
minus n
2.
upon 2.
Perfect. M minus n upon 2. Okay. It should be multiplied and divided with m minus n upon 2. So limit x approaching 0 to sine m plus n upon 2 x. Now there is x over here. Okay. Already there is one x. So m plus n upon 2. Okay. So this we multiplied. So on the top, again, I have to multiply so that it gets cancelled. You know? You should not cancel it, but then it should be cancelable. Okay. I'll just write this once again. Limit x approaching 0 to sine m plus n by 2 into x. There is one x down, so multiply by m plus n by 2. To eliminate it, we have to multiply it over here. Now there is one more term. Sine m minus n by 2 into x.
What's n minus m?
Sorry, n minus m. So n minus m by 2 into x, and this is n minus m by 2. N minus m by 2. Okay. Guys, don't write x over here. Huh? Don't write x over here along with this term. We are just multiplying with this term, not with x. So by mistake, don't just write at x over there. Now this part and this part is 1. So 2 into 1 into this, I am writing it as n plus m upon 2. I just reversed it. Again, this is 1. And this part, no need to reverse, n minus m by 2. So 2 to cancel because there is multiplication. N plus n into n minus n. N square minus n square by 2. Okay. And x approaches 0. So m plus n by 2 into x also approaches 0. M minus n by 2 into x also approaches 0. Mention this on the safer side. Guys, anyone with any doubt in this problem? Anyone with any doubt in this problem?
No,
No, sir.
Great.
Sir, I had one doubt.
Ask, please.
Why do you write m minus n upon 2 x approaches 0?
That we have been discussing right from the beginning, right? I'll tell you. See this problem. Okay. So you have copied this problem, right?
Yes, sir.
Now this particular part is 1, the blue colored part.
Yeah,
But then the formula is for x. This has to be x, na?
yeah,
These three terms have to be x. But then we applied the formula for x by 2.
yeah,
So x approaches 0. Okay.
yeah,
X by 2 will approach 0 by 2.
yeah.
Dividing by 2 on both the sides. And what is 0 by 2?
0 by 2, 0.
Yeah. So we are making the formula applicable for x by 2 also.
She's asking why you did m minus n instead of
Yeah.
n minus n, because
Yeah.
C, it is d
that should
minus
be-
c, no? D minus c.
Yeah. That is a human error. Okay, so I thought conceptually you're not understanding. Now it is correct, everyone?
Yes.
Yes, sir.
Yeah. Sorry for that. Let's go to question number 14. Limit x approaches 0 to sine square 3x upon x square. Now you know the basics. We have a common square over there, so we can group the square. Over there, right? Fine. Now, girls, can you tell me what to do within the bracket? This bracket.
Multiply and divide by 3.
Multiply and divide by 3.
Perfect. So 2 sine 3x, and 3. Is this correct?
No, so
Multiply.
he will be inside the square.
Multiply and divide by 3. I was supposed to ask that, no problem. So basically, this is incorrect. Why? Because we cannot take this 3 outside the square. Because the manipulation is happening within the square. So that was the mistake purposely which I had shown. Many students do commit it. You have to write steps very systematically. Now this particular part is 1. So 2 bracket 1 into 3 the whole square. Okay. Whatever is the answer. X approaches 0. So 3x also approaches 0. This also you mentioned. The answer is 18 over here. Okay. Guys, are you clear with this? Everyone?
Yes,
Hello,
sir.
hello.
Yes, sir.
Yes.
Acha, question number 18 is self-study, yeah? Because question number 18 is same as question number 13. Question number 18 is same as question number 13. So I'll take you to question number 15. Okay. Right. So question number 15 right now. Yes. Can someone apply any logic? Can you think?
So we convert 1 minus cos 2x
2
to
cos
2
square.
sin square x. 2
2 cos square x.
is cos square or sin? Okay.
This is a
No,
direct
it's
form.
sin square. It can't be cos square.
Sorry,
Then
sorry.
you won't be able to apply the formula.
Okay.
Hey, that is not the reason.
Yeah, yes, and
Yeah. Minus is sine square. Okay. And if it is plus,
Okay,
1
sir.
plus, which is 2 cos square x. Okay. Yeah.
Yes.
Now again, the problem over here is there are two signs, but then there is only one x. So there is one more sin x left. So I'll multiply that sin x with x and multiply with x. Divide with x and multiply with x. I repeat. Again, I'm teaching one extra step. Okay. So there are two signs. So sin x into sin x. There is one x, so x is written over here. Fine. Now first sign is sorted. This is sorted. This is not sorted. So which angle is required down? X, the same angle. Okay. So multiply and divide with x. Now this is also sorted. Okay. So the answer is 2, 1, 1. Yes, guys, please tell me, everyone, what about this x? ये तो रह गया.
0.
0.
Substitute that.
Correct. This will be 0. So the answer will be 0. Please copy.
Sir, instead of in the second sin x, instead of multiplying and dividing by x, can you just substitute the x ka value as 0?
Correct.
With 0 anyways. Yeah.
But then see, that is simple over here. I am making you that habit for the entire exercise.
Okay, sir.
That whatever angle is there down, it should be same.
Okay, sir.
Okay.
Understood.
So even in exam, if you write sine 0, not really a problem. If you don't this multiplication and division by 2, and if you put sine 0 over here, it's okay.
Okay, sir.
Yeah. So let us go to question number 16 after this. Guys, I have asked Vicky sir to give me his class so that I could complete a greater chunk of problems today. And he was kind enough to give me his session.
So till what time?
So it will be till 5 o'clock. Or rather, if even if I complete this exercise, I'll just close this session. Okay, but then I require time. Question number 16. Limit x approaching 0, 1 minus cos 4x upon x square. Now, guys, this should be easy for you. Come on, tell me. What is 1 minus cos 4x?
Two sine square 2x.
Very good. 2 sine square 2x. Okay. Very good, Agrima. Now we have a square over here at the top in the bottom. Okay. Two over here. Yes, guys. What to do over here within the bracket? Can someone guide me over here?
So multiply and divide by 2
Perfect. Within the
within the brackets.
yes, perfect. So sine 2x, this is also 2x and this is 2. And square outside, obviously. Okay. Yeah. Guys, what about this red colored part?
1.
1.
So 1 into 2, the whole square. Answer is 8. X approaches 0. Therefore, 2x also approaches 0. Yes, Shriya, Samika, you are attending?
Yes, sir.
Yeah. So that was question number 16. Question number 18 I have given you for self-study. I'll go to question number 17. . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . limit x approaching towards 0, 1 minus cos mx, 1 minus cos nx. So 2 sine square, come on, tell me. Half angle, double angle.
M by 2x or mx by 2.
Correct, mx by 2. And this will be 2 sine square nx by 2. Okay. 2 will get cancelled. Now since we have
divide by mx by 2.
Yeah, but then I would recommend if some power is common na, you take it common and then do that. Okay, it will be always better. It will be always better. Right?
Oh, okay, sir.
Yeah. Now this is sine mx by 2. Sine mx by 2. So beneath sine mx by 2, which term should be there?
mx by 2.
Correct. Perfect. And this is sine nx by 2. Sine nx by 2. So beneath sine nx by 2, which term should be there?
nx by 2.
Nx by 2. Nx by 2. Okay. Now in the numerator, we need to multiply and divide with mx by 2. In the denominator, we have to multiply and divide with nx by 2. All within the box bracket. So see how I'm writing. Sine mx by 2 upon mx by 2 into mx by 2. Sine nx by 2 upon nx by 2 into nx by 2, the whole square. Guys, what are these circles?
1.
Great. What will happen to this x which is left? This x and this x?
So they'll cancel.
They'll get cancelled. Perfect. Because this is multiplication division. Okay. So final answer. 1 into m by 2. Acha, by the way, 2 and 2 will also get cancelled. This 2 and this 2. Okay. So 1 into m upon 1 into n, the whole square. The red color circles are 1. So can someone tell me what should be the final answer then?
M square upon N square.
Correct. M square upon n square. Now one instruction will give to the paper corrector. Since x approaches 0, mx nx by 2 approaches 0 and mx by 2 also approaches 0. Okay. This you inform to the paper corrector. Right? Next problem. That is question number 19. It seems to be a difficult one, but then it is not. Once you know the formulae of TF, that is trigonometric functions, half angle, double angle, compound angle, factorization, things are pretty simple. Okay. Fine. So, question number 19. Limit x approaches 0, 3 sin x minus sin 3x upon x cube. Okay. Sin 3x. Anyone, what is the formula for sin 3x?
3 sin x minus 4 sin cube.
Correct. I think Agrima, you said the right answer. Okay, but then this bracket is very important. The bracket is important because of the minus sign in between. Okay. So 3 sin x upon minus 4 sin cube x. Sin cube, x cube, sorry. So 3 sin x gone. Minus minus is plus. This minus into this minus is plus. Okay. So 4 sin cube x upon x cube. 4 sin cube x upon x cube. Okay. So limit x approaching 0, 4 sin x upon x the whole cube. What is sin x upon x?
1.
Correct. This is 1. So 4 into 1 cube. This will be 4 into 1 cube.
4.
Correct. Four into 1 cube, which is 4. Right?
Sir,
I'm giving you a 5 minutes break, everyone. I'll
Sir.
reconnect in 5 minutes. Yes, tell me.
Can you send the 19th question on the group?
Oh, sorry. The question is this, whatever the first line, na? But then I will send it, don't worry.
Okay, thank you.
We'll rejoin after 5 minutes. Limit x approaching 0. Sin 3x. Cos 2x upon sin 2x. Okay. Now cos is really not a problem for us because cos 2 into 0, that will be cos 0, and cos 0 is 1. Okay. Can someone guide me what to do with this sin 3x? Anyone? What to do with this sin 3x?
3 sin x minus 4 sin cube x.
Yes, that is the triple angle formula, but then that formula is really not required.
We can
Multiply
just
and
take
divide with.
3 below and multiply divide.
Okay. And down also. So see, even if you apply that formula,
So won't it be 3 not 3x?
3x is required now down because there is 3x over here.
No, sir, when you multiply it again. Oh
So
no,
3,
never mind. Yeah.
fine,
Never
na?
mind. Yes, sir, sorry, my bad.
No problem. Okay. So this and this will turn out to be 1. Okay. Guys, what about this x and this x?
Answer.
So you can cancel it.
Cancel it out. Okay. And someone can you please tell me what about this cos 2x?
1 because
So it'll
cos
Correct.
become cos 2 0. So then it'll
Perfect.
become
Perfect.
1.
Yeah.
1.
So this is going to be 1 into 3, 1 into 2, cos 2 into 0, which is cos 0, and cos 0 is 1. The answer is 3 by 2. The answer is 3 by 2. And also mention x approaches 0, therefore 2x also approaches 0 and 3x also approaches 0. Okay. Yes, batch 1 girls. Prajna, Samika, Arushi. Did you understand?
Yes, sir.
Yes, sir. Yes, sir.
Ania, boys. Arinjay, Krishiv, Shiv,
Yes, sir.
Bansali.
Sir.
Okay. This was question number 20. Let's go to question number 21. Okay. Question number 21. Yeah. Limit x approaching 0, x square 1 minus cos x. 1 minus cos x, I will convert it into 2 sine square. What is the angle? Anyone? What is the angle?
X by 2.
X by 2. Perfect. X by 2. Okay. Limit x approaching 0, half x upon x by 2 the whole square. Group the square terms. Group the square terms. Okay. Now there is sine x down. Sine x by 2 down in the denominator. So beneath sine x by 2, which term should be there?
X by 2.
Correct. So multiply and divide with x by 2. Multiply and divide with x by 2. Okay. Now what about this? Anyone? What about this?
1.
Correct. At the same time, this x and this x is getting cancelled. What will happen to this 2?
It'll go up and then it'll get squared.
Correct. Good. Very good. Perfect. So 2 will go up in the numerator. Okay. So half within the bracket, 2 has gone up. This is 1 the whole square. Okay. So 4 upon 2, which is 2. Answer is 2. And you also have to mention as x approaches 0, x by 2 also approaches 0. This also you mention. When we conduct a test on limits, you have to sit with the recording and practice. Please. So this was question number 21. Okay. Let's go to question number 22. Let's go to question number 22. Fine. Limit x approaching 0. Sine 3x minus sine x upon sine x. Now again, you might feel that, okay, we'll apply triple angle formula over here, but then that's really not required. Okay. We'll adjust each and every term. So sine 3x will be divided with what? Anyone? Divided with what?
3x.
Correct. Good. Divide and multiply. Sine x will be divided and multiplied with what?
X.
X. Down also. Divide and multiply with x. Okay. Now in the numerator, before we do anything else, this is a very crucial step. This x will take common. in the numerator. Okay. This x will take common. So limit x approaching 0, sine 3x upon 3x into 3 minus sine x upon x is taken out common, upon sine x upon x into x. Now this x and this x will get cancelled. Now what are these circles? What are these circles? What are these circles?
So 1.
Correct. So 1 into 3 minus 1 upon 1, which is equal to 2. Okay. Yeah. Let us go to question number 23. These are very simple problems. Question number 23. Acha, by the way, right over here, x approaches 0, so 3x also approaches 0. Okay. Question number 23. Limit x approaches 0, x cot 2x. Take that cot down. It will be tan 2x. Now there is a tan term. What to do with this tan 2x? Anyone, can you guide me?
So tan 2x upon 2x into 2x.
Correct. Tan 2x upon 2x into 2x. Okay. Multiply and divide with 2x. Fine. Now before you do anything, this x and this x is getting cancelled. This circle is 1. Okay. So 1 upon this 1 into 2. So the answer is half. And what you are supposed to mention? X approaches 0. Therefore 2x also approaches 0. Okay. This was 23 sub question 1. Let's go to 23 sub question 2. Twenty-three sub question 2 is the last problem for the day. Limit x approaching 0. Now I want everyone to answer. Come on, tell me. Slowly. Don't be in a hurry.
X upon 1 upon sine 3x.
X upon sine 3x it is. Okay, not 1 upon sine 3x.
Sorry, sir. Yes.
No problem. Yeah. So she was absolutely right. Cosec is written as sine 3x. Now my next question to all of you is, which term to target? We should target which term?
The 3x, sine 3x.
What to do with sine 3x term?
You multiply and divide it by 3x.
Correct. So limit x approaching 0, x upon sine 3x, 3x and 3x. Okay. This x and this x is getting cancelled. There is 1 left in the numerator. This is 1. So 1 upon 1 into 3. which is 1 by 3. And since you're applying the formula over here, x is approaching 0, therefore 3x also approaches 0. Okay. So guys, good job. Remaining 5 problems, I'll tell you what to do with those remaining 5 problems. Okay.
Yes,
Thank you.
sir.
Thank you for your patience. Bye.
So,
Yeah, tell me.
by any chance, could you extend the date for the homework submission?
Yes, sir. Can
Yes,
you like?
I will do that. I will do that. I will do
Thank
that.
you, sir. Thank you, sir.
Okay.
Thank
Yeah.
you, sir.
Bye.
Bye, sir. Thank you, sir.
Bye, sir. Thank you.
Bye, sir. Thank you,
Bye,
sir.
sir. Thank you.
Bye, sir. Thank you.
Bye,
Bye.
sir. Thank you.